Welcome back to another FlexSim tutorial. In this video, we shall discuss how to use an experimenter to specify several scenarios and run many replications of those scenarios. For this, we will be examining a very simple setup where a single worker is assigned to transport the items from source to processors and then to a sink as shown. Here we want to see if we can maximize the throughput of this system by adjusting the position of the processors. Let's start by building the 3D model. To build this model, make sure your 3D model window is open and active. From the library, drag the following 3D objects into the model: a source, a processor, another processor, a sink, an operator, and a dispenser. Create the necessary A and S connections as shown here.
Click on the source. Set source 1 to use transport. Set the process time of processor 1 to have a normal distribution with mean value 10 and a standard deviation of 2. Now repeat the same for processor 2, but this time with mean value 12 and a standard deviation of 3.
Now, click on source 1. Click on the position button in the properties and set the position reference to direct spatials. Set the location of the objects as given in the table.
Now you need to create two parameters. Each parameter will be linked to a processor. On reset, the processor will move so that its X location matches the value of the parameter. For this, go to Toolbox, double-click on the model parameter table called Parameters to open it. Click and drag the parameter table view to dock it to the right of the 3D view. Click on the value cell of parameter 1. A drop-down button will appear. Click this button to open the parameter value properties. Set the lower bound to 7 and the upper bound to 13. Click the sampler button next to the reference field. Click on processor 1 in the model, point to properties and then choose setup time. Click the properties button next to the onset field. Change property to location.x. Click on the parameter value properties to close the pop-up. At the top of the parameters table, click the up button to add another parameter. Click on the value cell for parameter 1 to select it. Press Ctrl+C to copy the value. Click on the value cell for parameter 2 to select it and press Ctrl+V to paste the value. Set the lower bound to 17. Set the upper bound to 23. Click the sampler button next to the reference field. Click on processor 2 and choose processor 2. In the toolbox, double-click the performance measure table called Performance Measures. Dock it in the same plane as the parameters table view. From there, click the value cell for Performance Measure 1. Click the button to open the Performance Measure value properties. Click the sampler button. Click on Sync 1 to sample it, then point to Statistics and choose Input. Click outside the Performance Measure value properties window to close it. Now that we've created the parameters and performance measures, we'll set up an experiment job to run replications of some scenarios. In the Statistics menu, choose Experimenter. The Experimenter window will appear. Check the box in the parameters list. This will add all the parameters in the parameters table Create 5 total scenarios by entering 5 in the scenario count field. Enter scenario names and values as follows. Now, go to the Run tab. Click the Run button. Each scenario will be run 5 times, and the results of the performance measure will be collected at the end of each run. Once the experiment is finished, click the View Results button at the top. This will open a window where you can get data on the performance measures for the scenario. In this example, we only have one performance measure, but if you had multiple, you could see the results for each in this window. From the results, we can conclude that if the goal is to maximize throughput, then the close scenario is the best option. That's how you use FlexSim's experimenter to optimize processor placement and maximize system throughput. Thanks for watching.